And the reason why we spend this much time on the modifier system is that it's a cool and flexible way to add a lot of variation to your game, right? So this can be heavily reused across different genres and games. It's a very general and very robust system to make your game more interesting very easily, right? So hopefully this makes it easy to create interesting combos and add a bunch of content to the game. We just need to hook this up with the TraitBonus system, because trait bonuses are usually modifiers. Not always, but most of the times. So what we do is we have our data folder here, and we have a folder for traits. Now here we have trait.gd and all the different traits that are available in the game. And here we can either dump every bonus into this folder, or we can create another folder. I don't know which one is better. In the reference project, I created a new folder for bonuses, so let's just stick to that version. So right click on the traits folder, create a new folder. I call this bonuses. Click on OK or press enter. And here we want to add a new script first. So let's right click on the new folder, create a new script, and call it trait_bonus. And let's inherit from the resource class. Click on create, expand the folder, double click on it to open it up in the script editor. Now, this will serve as a baseline for all the other trait bonuses, so we don't really need to do much here. We'll provide a custom class name called TraitBonus, and we'll define one method that we need to override, which is called ApplyBonus, and we'll pass in a battle unit. So we usually need a battle unit to provide a trait bonus to, so we need this as an outside dependency. We leave it as empty for now, and we just override this for all the other classes. Now, one thing that was added in Godot 4.5 is abstract classes. So if we press F1 and search for @abstract and click on open, it says that it marks a class or a method as abstract. And they cannot be instantiated directly. It is meant to be inherited by other classes. Attempting to instantiate one will return an error, and abstract methods have no implementations, right? So this is a concept from object-oriented programming. If you take a look at the example, for example, we can have something like abstract class shape, and it has an abstract function draw. So we say that all the classes that inherit from the shape class should have a method called draw. And this is kind of exactly what we're doing here, right? So if we want to, we can actually use abstract classes for this, and then we don't have to provide this empty method body. Another benefit of this is when we want to create a bonus resource in the file system, TraitBonus won't be offered to us as a resource we can create because it's an abstract class. It cannot be instantiated. So why not try it, right? So we have to add this add abstract notation to the top of this class name and also above our method. So we'll say that this is an abstract method, and we immediately get an error message that an abstract function cannot have a body. Awesome. So we don't have to leave this empty. And now we have our definition, right? And this exactly tells us that, okay, this is just a baseline that we should have. And one cool addition is that we don't have to have this leading underscore. The reason why I had this leading underscore before, let me show you. So if we undo this, and if I delete this, I have a warning. And if I click on the warning side, I have an unused parameter for battle unit. Yeah, I never used it because this is empty, right? So it makes no sense. But if I override that to be an abstract method, I never tried it, but hopefully the warning message should disappear. Yeah, and it does. So I don't have to say that this won't be used. This will be used by whoever extends from this TraitBonus class. So it's a much more elegant solution to the same problem using these abstract classes, because we provide that contract that all trait bonuses will have to create this method, right? So let's save this with Control S using these abstract notation. Now we can just create all the specific bonuses like the ElfBonus, the Ranger, the Viking, and so on. And abstract classes make it a bit easier to make us remember that we need to do this apply bonus method, but I would still prefer using the script template functionality that we already know and use. So let's go to our script templates folder, right click on it, create a new folder. We'll call this node and mind the uppercase N here. It needs to match the class name for the node class. And we have a unit ability, which is a node 2D because we instantiate it inside the game's space. But we have to use the node template here because resources won't be a part of even the scene tree as well, right? So last time I checked, you couldn't use resource here because it didn't work. But why don't we try it? Hopefully they fixed it. So let's rename this to resource instead and let's see if it works. because we do want to instantiate from the resource class, right? Because TraitBonus is a resource. So let's right click on this and create a new script, and we'll call this TraitBonus template.gd, which inherits from the node class. We'll have to override this anyway. So let's just click on create and double click to open it up in the script editor. And it will be pretty straightforward. We have some metadata that we provide. We call this TraitBonus script, and we use this to apply specific bonuses to battle units based on trait data. And we can just say based on trait resources. And for the class name underscore class underscore will be replaced with the file name, which is super useful. And we extend from the TraitBonus class. Now, this is an abstract class, remember. So if we save this, hit Control S and remove this implementation here, we should have an error message, and we do. It says that class must implement TraitBonus.apply bonus and other inherited abstract methods, or be marked as abstract. Awesome, so we do have an error message reminding us that we need to make this. Having this apply bonus method and access to a battle unit makes it so it's very flexible. We can do whatever we want with trait bonuses, but for the template, I just wanted to provide the most frequent use case, right? So probably most of the time what we want to do is to add modifiers to the units, right? So elves get an attack speed boost, fighters get an AD boost, guarding units get an HP boost. So it's pretty common to just add modifier bonuses to units, right? So what we provide as a template is that we have an export variable, which is a dictionary where the keys will be modifier types, marking which modifier we want to provide bonuses for, so we can mix and match them. And the values will be modifier values, which will contain the data that how much bonus we want to provide and what kind of bonuses, right? So percentage base, flat base, and so on. And in this case, what the body of this function should do is pretty straightforward. We grab all the modifiers that are present as keys in this export variable dictionary and just add those values, right? Grab the modifier, ref count it, and call the add new value method. So this is pretty straightforward, and we can save this with Control S, and this will do for most traits, but whenever we want to do something more interesting, we can override this. Let's see if the resource can be used for templates. So now that we have our system in place, we can actually code some of these bonuses. So let's do one for the elves. So right click on the bonuses folder, click on create a new script. And for our templates, if we enable it, we should have our template here, but I can see that it doesn't work for resources still, right? It doesn't matter that we inherit from the resource class. We want to say that we inherit from the node class, otherwise it won't be offered to us here. So I believe that this is a limitation of this system, but if we rename this folder from resource to node instead, we still have our file here. We can close these, save everything with Control S, and if we scroll up, right click on the bonuses folder again, create a new script. And now we have our TraitBonus script as a template. If we click on it, we have our metadata as well, and we can just rename it to ElfBonus.gd. And if we create ElfBonus.gd, the class name will be replaced, and the default code that we provided will be added as well. Awesome, so we actually don't want to change anything for the ElfBonus. It will be fine to just provide an attack speed boost. So let's save this with Control S, right click on the folder again, create a new script. This time we'll do VikingBonus.gd. So Bjorn can have some sort of an upgrade as well. The template would be the same, click on create, double click on it. And let's make this a bit more interesting. So let's say that Vikings have the following trait bonus. When they fall below a specific HP threshold percentage, they will change their color to red and go into a berserk state, providing a huge attack speed boost before they die, right? So how would we do this? First of all, let's change the export variables, right? So instead of having these modifiers, we'll have an export range for the HP threshold percent that we have to fall below to activate this trait bonus. This will be between 1 and 100%. We'll have a color, which will be the modulation that we want to apply to the unit. So we visually communicate this. And there will be just one modifier value, which will be the attack speed bonus that we provide for this berserk state. Now, to make things a bit easier, we'll also provide a member variable for the attack speed modifier of the unit, so we can have access to it throughout the whole class. Now the question is, what do we want to do when the apply bonus method will be called? Remember, this will be called once when we start a new battle. So this won't be that good for the Vikings, because when you start a battle, you won't fall below the HP threshold percentage, probably. So what we need to do instead is to connect to the stats changed signal of the battle unit, so we can be notified when the HP of that Viking unit changes. So we connect to that signal and bind the unit as a parameter, so we can have access to all the member variables and everything that is stored inside the unit. But we are yet to implement this callback method here. And we can also grab the attack speed modifier from the modifier handler, just so we store it in that member variable. So when the HP falls below the threshold, we can easily add a new modifier to it. Because we don't want to add that attack speed boost when the battle begins, only when it's feasible, right? Now, how do we implement this callback method? So the first thing we do is we grab the attack speed modifier and see if we have a Viking trait modifier value. Because if we already have this active, we don't want to activate it multiple times. So this essentially serves as a safeguard to say that, okay, if we already have that bonus applied and the attack speed modifier has that Viking trait, we can return from this method because we don't want to stack it multiple times. That would be way too OP. Now, what we need to calculate is the HP percentage of the unit when the battle unit stats changes, so we can decide whether we fall below the threshold or not. Now we could do this here, and the calculation would look something like this, right? We can grab the health of the battle unit and divide it by the maximum health of the same battle unit. Make sure to convert one of these values to float, because if we divide two integers in GDScript, the result will be an integer as well. We could do this here, but again, I don't really want to do calculations that shouldn't be done inside this bonus class, because what if I will add more bonuses that rely on the current HP percent of the unit? This functionality belongs not here, but where? Where should we add this? Hopefully you understand the problem. If I were to add another bunch of bonuses that rely on the same information, then I would have to copy and paste the same logic. Now, if for whatever reason the battle unit stats changes, I suddenly have to refactor 10 of my bonuses, and I shouldn't do that, right? Like, that's not the responsibility of the Viking bonus at all. So what we can do is a minor refactor. If we search for unitstats.gd, let's click on the get max health method, and we can just add a new method here, right? Called get health percentage, return a float, and we do the same calculation, like divide the health by the float value of the maximum health. And it's much cleaner to do this here, because all the other bonuses that will rely on this information can just query it from the stats resource, right? Because they have access to it anyway. And then this whole line can be replaced with the if statement instead, where we say that if the get health percentage is less than or equal to the threshold that we provided, then we can do two things. Add the new value, the attack speed bonus that we have as an export variable, to the modifier, and set the battle unit's modulate property to the color, so they visibly turn red to indicate they berserk, right? This is how we can use the same entry point to these bonuses while having the flexibility to create more complex or more interesting bonus versions than just adding a modifier straight away, right? So let's save this with Control S, and this is all the scripting we need to do to have these bonuses, but now we need to add those bonuses as well, because if we double click on the elf resource, we have our unit requirements export variable, but if you remember, we commented out the part of the script where we actually provide these bonuses. So let's press Ctrl-Alt-O and search for trait.gd. And now we can delete this hash mark here, and we do have our TraitBonus class. So now we can actually provide the bonuses to the units as well. Save this with Ctrl-S. Now we still need to do a bunch of things here soon, but before we do that, let's create the bonuses themselves. So if we go back to 2D view, we have our definitions here. But if we click on the elf, we'll see that the trait bonuses are empty. So let's change the size to 2, and the unit requirements, to make it easier to test, let's make sure that 1 elf is enough to get the first level of bonus, and let's say 3 are needed for the second level. And you see that these are empty. So you can either add them here, and if I click on the arrow, you see that ElfBonus and VikingBonus appears here as viable resources as trait bonuses. Because for the script, you see we use TraitBonus here, but another advantage of using the abstract notation is you see TraitBonus is not here. because that's an abstract class. We cannot instantiate it. We cannot create one TraitBonus. We can only create ElfBonus and VikingBonus that are derived from the TraitBonus class. So it's nice. With our old solution, TraitBonus would be listed here, right? It's not the end of the world, but it's much more elegant this way. Whether you create the ElfBonus resource here and add the modifiers here so everything is in one place is up to you. The alternative would be to create the bonuses and save them as separate resources. The reason why I prefer this because as soon as you start stacking these, the inspector has to be really big to make sure you see everything. So if I click on ElfBonus here, open the dictionary, then I have to add a new modifier value to this, and you see, it gets confusing really fast, even with the color coding, I think. But the advantage is that everything is in one place. So you can do it this way, or the alternative would be to right-click on the bonuses folder, create a new resource, search for bonus, and you'll see that the TraitBonus is not viable. I cannot select it. I cannot create one because this is an abstract class. But I can create an ElfBonus and say ElfBonus level 1, for example. Double click on it, and we have to provide this dictionary, right? Because this is the more basic version. So in this dictionary, the key will be the unit's attack speed, and the value will be a new modifier value. And let's say that this comes from the elf trait, and it will be percentage based. And let's say we give negative 0.1, which is 10%. Right? That's the bonus we provide. And let's not forget to do this. When I created the reference project, I forgot it many times, but you have to actually click on this add key value pair for dictionaries. And that's when it gets added, right? This line here. So we have this. And since we have 2 levels of bonuses, this is good when we have one elf. But if we right click on this, create on duplicate and create one for level 2, double click on it. So this is the level 2 version. Then for the modifier value, we can change this, but make sure to, before we do that, click on the arrow and click on make unique to make sure that we don't change the other one, right? So let's change this to 0.25, let's say. So when you have 3 elves on the board, then you have a 25% attack speed bonus. So if you double click on this, we'll have 0.1, double click on this, we'll have 0.25. And now when we go back to the elf, it becomes actually a bit easier to change this. So if we change the array size to 2, click on the arrow, click on quick load, we'll have ElfBonus level 1, click on quick load again, and ElfBonus level 2. I think it's a bit cleaner this way, and you can edit it either way if you wanted to here. It's really up to you what you prefer. This stores more things explicitly on the disk or in the file system, but I don't think that's a problem, right? Because if I press Ctrl P, search for ElfBonus, it becomes pretty easy to find what I'm looking for. Press enter and this will be opened in the inspector. Now for the VikingBonus, to make this easier, I only create one level. So let's create a new resource, select the VikingBonus, call this VikingBonus level 1. And let's use a pretty big HP threshold percentage to make sure that it triggers, and then we can lower it. I'll use 75%. For the attack speed bonus, create a new modifier value, and let's not forget to fill in the source. And we'll use Viking_trait, and let's make this a percentage base value as well, and let's make it something crazy like a 0.7%, like a 70% attack speed boost. That's a crazy big amount, right? And if we're done with this resource, we can double click on the Viking resource, and let's move the unit requirements down to 1 level, and 1 unit would be enough to make it easy to test. For the bonuses, we need 1 level as well, so these 2 should match, and quick load our VikingBonus level 1. Save everything with Ctrl S, and let's pat ourselves on the shoulder because we created the bonus system, we created the modifier system, and we refactored the whole trait handling system as well. That's a huge milestone, but if we play the game, what happens? I put in Björn and Robin and get an error message immediately. Okay, what did I screw up? Invalid index out of bounds. Okay, so we have Björn here. Unit requirements should be an array somewhere. size of 1, and my levels property is set to 2. So that's the problem, right? So when we edit this, we need to make sure that levels matches the size of these arrays. Okay, so let's resize that to 1, save it, and go back to the elf. It's at 2, so this shouldn't be a problem. Okay, now let's play it again, because that's not what I wanted to show you. If we add in Björn and Robin to the game, you see we have the elf and the Viking traits active. But if we start a battle, probably we don't notice any changes straight away, right? Björn definitely have fallen below 75, and you don't see the modulation happening. Why? What's the problem? What is it that we didn't do? We have all these resources, we set up everything correctly. We did a bunch of work, but nothing really changes. See, the problem is we haven't really hooked this up. So the battle handler, if you remember, we didn't touch it. So when we prepare the fight and set up the bunch of things for the battle unit, we don't really see any trait bonuses applied or anything, right? So the one final thing we need to do here is to actually hook this system up. So that's what we'll do next. If you like my content, please consider checking out my Ko-fi page, where you can donate one time or become a member and get early access to all my content and videos. Okay, so the final step is hooking up our new system. And before we can do that in the battle handler, we'll have access to the battle unit's traits, right? And we'll also provide an external dependency for the trait tracker, so we can compare the current unit's traits and see if any of them are listed as an active, right? And then we can add the bonus. But to do this, we'll start with our trait.gd file, with the resource where we have our traits, to provide some utility, making that easier, right? It's the trait's responsibility to provide the currently active bonus, because remember, we have multiple bonuses based on how many levels a trait can have, right? So we need to check if we have an active bonus, which one of these levels we reached. And we do something similar in our getLevelsBBCode method, because we have this reach level variable here where we filter through our unit requirements array and only keep those where the unit count is greater than or equal than the requirement. And basically we want to do the same for our trait bonuses array. So we should extract this functionality out, because we don't just want to use our reach level in the BBCode method, we want to provide one for the bonuses as well. So we'll do a slight refactor here, and the first thing we do is actually extracting out this functionality where we grab the reach levels, right? So let's go all the way down. We have our toString method here, and above that, we can have a method like this. We'll call it getReachLevels, we'll get the unique unit count and return an array of integers which contains all the reach levels we have, and we'll use the same filtering we have in our BBCode method. Now that we have this, we no longer to do it again inside our BBCode method. Instead, what we can do is we can just call that, right? I think it makes sense, and it was a slight mistake from my end. Since this is an array, I would use plural for this. So I would call this reach levels, because there are multiple levels we can reach simultaneously. So let's just copy this over and add that S at the end here as well, where we reference it, right? So we added an S here and replaced this line of code after extracting out this functionality. So far so good, it's not too bad. So what we can do is, above our getLevelsBBCode method, we can create a new one called getActiveBonus with one parameter, which will be the unique unit count for that specific trait. And we return a trait bonus, hopefully from this one. First we grab the reach levels array, which will be the same we used in the BBCode version, right? So this is why we extracted it out to its own method, because we can reuse it in both places, both for the BBCode and for the ActiveBonus script. Now we do a safeguard. If the array is empty, it means that we haven't really reached any level, so we can return null because no bonus should be applied in this case. Otherwise, we just grab the last one that we reached. So we grab the trait bonuses array, see the size of the reach levels, which will be how many levels we reach. So let's say we have 2 levels from the 4, then this will be 2. 2 minus 1 is 1, which is the index of the second bonus from this array, right? So now that we have this function, we can use this in the battle handler and actually hook everything up. So let's save this with Ctrl S. And we should go to the battle handler next. I have it open here, but if you don't, press Ctrl+O and search for battlehandler.gd. And the first thing we need is a reference to the trait tracker, right? If we go back to the architecture overview, this is where we started from, right? So we do need to have access to what traits we have active when the game starts or when a combat starts. So the reason why we wanted to split this from the UI is so that we have an explicit node handling and tracking all these traits. So we have an export variable reference to the trait tracker. We'll set this from the inspector, and now we immediately have access to this information. So adding this will be pretty straightforward. We have some utility methods here like cleanup fight or prepare fight. Somewhere here we can add another one. Let's see. Let's add it below the setup battle unit, for example. And this method will be called add trait bonuses. And we pass in the unit as a parameter, and it will be pretty straightforward. We iterate through all the traits that a unit has, call this unit trait, and we see if the trait tracker's active traits array has that trait inside it, right? This means that, okay, elf trait is activated while ranger is not. In this case, this if statement will be true for the elf trait, but not for the ranger trait. And if it's true, what we do is we use that method we just created. So we'll use unit trait, which is elf in this case, .get active bonus. So it will get the proper bonus resource, right? Either level 1 or level 2, depending on how many elves we have this trait activated with. And then what we do is we grab the unique amount of elf units on the board. Again, this is available from the trait tracker because we have the dictionary, right? Where the trait will be the key, which will be the elf in this case. And the value we have instead will be the amount of unique units. And that's exactly what this method wants, right? The unit count. So now that we have our bonus, we can call the apply bonus method, pass in the unit as a parameter, and at the beginning of the fight, the bonus will be applied. Pretty straightforward, and this is why we did that whole bunch of work, reworking systems, establishing the communication lines, adding modifiers and all that, because on the high level, when we prepare a battle, all that can be done in 4 lines of code, right? It's pretty convenient, it's readable code, I believe, it's easy to grasp what's going on here. Now, the one final thing we need to do to hook everything up and test this is to actually call this method, right? So if we scroll down where we prepare a fight, we have the preparation for the player's units and we have the preparation for the enemy's units. For the demonstration purposes, we only need to call this for the player units, but this in a full game, I believe that this should be done for the enemy units as well, right? So we'll call the add trait bonuses method here and pass in the new unit as a parameter. And that's it. That's the only line of code we need to add here. And the bonuses will be applied to the unit. And that's about it. So if we save the game now, in theory, we should be able to test this. Just to make sure, I'll walk you through it again. So we provided an export variable for the trait tracker, added this new method for adding the trait bonuses, and called this method in our prepare fight for the player units in this for loop. Now, one thing that we still need to do inside our arena is setting the dependency. So for the battle handler, let's not forget that we have a trait tracker export variable and we haven't really assigned it. So click on assign. Select the trait tracker. Now that we have this set, we should be able to play the game. And if we put in Robin and the Björn, the Viking and Elf traits are active. So if we start the game, hopefully we'll see if Björn gets damaged, the modulation will change to red. You see that? The problem is he's not really attacking faster, right? And it's kind of hard to compare with Robin, that 10% attack speed bonus, but it didn't really seem like he was attacking fast either. So let's pause the game and investigate. Okay, so Björn is in his berserk mode because it's full red, and Robin should have the elf bonus, right? Again, we can use the remote scene tree to test this, or we can use testing code to rely on the modifier's toString method. So let's click on this show list of selectable nodes, and instead of providing game input, let's click on 2D. So now if we click on Björn, we'll have a bunch of nodes to choose from, and this area 2D at 44 is probably the battle unit. And from the properties, the member variables, I can tell that it is. So if we go to modifier handler, we'll have 7 modifiers, right? And one of these is the attack speed, but now I'm going to cheat. If we go to the script tab, press Ctrl+O and search for modifier, scroll all the way up, attack speed would be index 2. Okay, so if we go back to the game tab and go back to this remote node, if we click on modifiers, this is the one that's used for the attack speed, and it has one value, which is an object, and it's the Viking trait, and we have this 70% attack speed. Now if we click on Robin, click on battle unit, modifier handler, modifiers, second index, values, object ID, and we do have elf trait and negative 0.1. Okay, so we do have the modifiers applied, the system works. The only problem is that the auto-attacking mechanics that we have in the game don't really take these modifiers into consideration. So we can see that the modulation works and it uses the HP threshold we set, but the final thing we do in this video is to actually hook up or modify the auto-attacking system to use the modifier to change those values we want. How do we do this? Let's go to the script tab, press Ctrl+O and search for AutoAttack state.gd. This is the script where we handle auto-attacking, if you remember. Pretty long one, but we'll make sense of it. So how can we handle this? First of all, just to make sure it's easy to access this modifier in the whole script, we can create a new member variable called AS modifier as attack speed modifier. And we can set this, grab this reference to the modifier when we enter the auto-attacking state. And when we enter the state, what we can do is we store the actor unit, right? And at the same time, we store an attack speed modifier as well, which we can grab like this. Actor unit.modifier handler. This gives us a modifier handler node, and call the get modifier method, which requires a type enum. And this will be, of course, modifier.type.unit attack speed. Pretty straightforward. And now we have access to this. When we do this, when we enter the state, by the time we enter the auto-attacking state, the modifier will be applied because we do this when the battle begins, right? So the timer will be set when we enter the state. We have this method called setupAttackTimer. And if we scroll down, what we do is we'll use the stats for this, right? So we set the wait time to actor unit.stats.get time between attacks. See, the problem is for this one, we don't really use any modifiers. So instead, what we can do is we can calculate this. If this could be a one-liner, but it would be so long, I decided to split this into multiple lines instead by creating some variables. So what we do is we grab the base attack speed, which will be the same one we used here, right? Actor unit.stats.get time between attacks. And the final attack speed will be grabbing the modifier handler and calling that get modified value, where we use the base attack speed as our basis and use our modifier.type.unit attack speed as a type where we get this modified value from. And now all that's left to do is just to change the wait time of this timer to the final attack speed. And now we have this attack timer set up in a way that it actually considers any attack speed modifications the unit has. That's all there is to it, but one thing that you might ask is, why did we introduce this new member variable if we only set it here and never really used it anywhere else in the code? So if I select this and press Ctrl F, you'll see that this attack speed modifier wasn't really used elsewhere in the code. And this is sort of pointing towards the future. You are 100% right. There's no need to store this for now, because all that we really need to do is done here, and we don't really use the modifier for that. The reason why we do need it later on is very specific. So you can use kind of a cheese tactic in AutoBattler games. And if you think about it, when we enter this state, we set the attack timer once and we don't really change it, right? So we set it up once for that battle, and the time between the attacks will be fixed for the duration of that battle. But that's not always the case with auto-battlers. One tactic or strategy that you can use if you see that the battle would be close, you can decide to put an attack speed boost item on the unit while in the combat. And that's an interesting tactic because as a player or user, you expect that as soon as you attach an item to the unit, you get the bonus immediately, right? If I were to put an attack speed boosting item on Robin during the battle, we should recalculate the time between the attacks, right? Because it changes the modifier. So the reason why we need this reference later on is we need to handle this very specific possibility in the game, that I can actually change the modifier during the game. for this attack speed value. For now, we could delete it, or we can just leave it here and use it when we introduce items to the game, or we can do it ahead of time. It's just the explanation that we needed. I prefer doing the implementation part of this, of dynamically changeable attack speed, when we actually implement items. For now, we can leave this reference in, comment it out, or even delete it, because for this milestone, it's not needed to do this. For now, I'll just actually comment this out and leave it in the code for the future. Okay, so we don't need it for this one. What's needed is this, right? Because for now we don't have items. And that's the final thing we needed to change. If we save this with Control S and run the game one final time, let's not forget to change it back to input so we can actually interact with the game. And if we put in a Bjorn, just to make sure it's easier to see, I'll just only use one Bjorn at level 2. The Viking trait is active. So when it falls below 75%, it should start attacking like crazy. Okay, it's red. See that attack speed? It's way faster than it usually is. Even if we put in a level 1 Bjorn, who's hitting less than a level 2 one, goes into the cast state and starts attacking like crazy. It's really fast compared to the original attack speed he has, right? So now the attack speed is calculated in a way that it takes our modifiers into consideration, which come from trait bonuses. This is where we can wrap up our modifier system and our trait bonus and trait system in the game. Hopefully this was informative. This was a pretty big milestone that we have in the project. There are only a couple of things left to do. So that's it for this episode, and I'll see you in the next one. Bye-bye.